Okay, we should first introduce ourselves.
Oh, sure.
So wait, what is your like 2 sentence description of what you're doing?
Yeah, so I'm building Rose Labs.
So this is Andy.
Yeah, my name's
We're
Andy.
gonna re-chop the order. We'll probably have to put this in the beginning.
My name is Andy, and I'm building Rose Labs. Rose Labs is creating a custom harness to scale the number of agents. To scale the number of agents necessary to complete real-world long horizon tasks. So if you want your agentic system to go and run a fully autonomous business, create an entire event end to end, buy anything on the internet, or like string together events to create like a campaign, then you need a harness that can coordinate thousands to millions of agents in order to complete these like super complex tasks. Yeah.
So your harness actually doesn't look like a modern harness, because a harness today is like, yo, edit file or like do a grep, right? But if your harness is controlling a ton of other agents, then I presume these tools are like not relevant. Like what is the coordination?
Yeah, so like the basic tools are not terminal grep or whatever.
Yeah.
The basic tools are, first of all, there's like, you can spawn a coding agent, you can spawn a browser agent, you can spawn a general purpose agent, and then there's like another suite of tools for taking like real world actions. So you can like call people, you can message people,
Yeah.
you can wait for a specific event in reality.
So that's like a webhook based system?
It's not webhook right now. The way it works.
Is it like email polling? What is it?
So there's an Explore agent as well. The Explore agent's job is to pull in information from the environment. So the wait tool essentially, like the agent will specify some amount of like polling interval to check for some information to be available. So you can wait for an email to arrive, and then the Explore agent will go and like check your email on like that specific polling cadence. Or you can wait for like the price of BTC to go to like 70K. Or you can wait for some other part of the agent network to like finish its job. You can just wait for anything.
Yeah.
But those are like the basic primitives as in terms of like a tool suite. And then whenever, you know, a task gets sent to this harness, it'll go through this like recursive planning process. So each agent has like a planner node and an execute node. And so the task will come into that agent. The planner node will then decompose that task into like 3 to 8 different subtasks and spawn. I mean, it can spawn any type of agent or any type of tool, but in theory, it would spawn like more general purpose agents if it's a really complex task. And then those general purpose agents would then like plan to complete that task as well. And so you can have like this recursive process of taking some super complex tasks, like make me president of the United States, and like recursively break that down into like this string of hundreds of thousands of subtasks, which are then executed in like a distributed, like fault tolerant manner in the cloud.
Why do you think that like the other attempts at mega multi-agent harnessing and control have not worked? For an example, I heard of Gastown, which gains some amount of like Twitter virality.
Yeah.
And there's been a bunch of others. And like, okay, for an example, like Claude Teams.
Yeah.
I used Teams for a bit, but then I was like, it's just easier for me to just spin up multiple agents.
Yeah.
Like, why do you think these have not really gained like permanent fixture?
So
populace.
I think there's 2 main reasons. One of them is the fact that if the harness is not made extremely well, it's like super token inefficient. And like, for instance, Gastown, you have like 5 different types of roles, and they're all like approximating some like end state over a long period of time.
Yeah.
It's not like an efficient way of like, you know, achieving the end result. It's not like, let's just do this specific set of like tasks and then we're done. It's like this process-based like multi-agent architecture, which is extremely token inefficient. And so if you want to go and complete some super complex task, like make me a C compiler or whatever, right? Then you're now burning like, I don't know, probably billions of fucking tokens. And most people just don't have the token spend to be able to like iterate on this harness like effectively. So that's like number one. It's just like tokens are expensive right now.
Yeah.
And in 2 or 3 years, when tokens are like dirt cheap, having a massive multi-agent harness is going to make a lot more sense. But right now, it's like very hard to, figure out how to convert these massive amount of tokens into like real world value.
Yeah. So you think that just going to like 0.1 cents per million is gonna drive a lot of adoption?
Yeah, for sure. I think a good parallel too is like, if you look at society today, the only example of superintelligence that we have is like groups or societies of people, right? And so then the question is like, how do we go and build a system which can generate these societies? And that's what superintelligence is likely to look like. It's not going to be like some giga god model. But yeah, number one is like just having really cost efficient like intelligence per token is going to be a massive driving force to being able to actually like run like these agent networks.
But I think like the value of large group sizes in society is because each individual is doing an expensive internal evaluation of ideas, right? Whereas each agent in your super agent control system of subagents is not independently questioning the idea, is it? Because like very large societies tend to make better and better ideas because everyone questions many people question the premise of like how they do certain things, and then good ideas propagate throughout, right? But in your system of agent control, do you imagine the subagents actually refining and tuning what they're working on versus just taking instruction?
So I think the key question really here is, do you have a hierarchical way of spawning your agent network, or do you have like a decentralized way of spawning your agent network? And if you have like a decentralized way where each agent goes and joins the system and then like figures out how to contribute to the system in some positive way, you're going to get this like approximation, like each agent has their own values or reasoning stream, and then like over time the artifact that's being generated like gets better over time. Or you can have like a hierarchical approach. It's kind of interesting. It's almost like communism versus like democracy. Where you have this like hierarchical approach where like some plan head is like, this is how we're going to do this task. Let me break it down like over and over and over and over. And I think both of them actually have their merit. I don't think the only reason societies of people are helpful is because like they can each independently approximate some like metric. It's also because like you can just parallelize super well, and also because you can manage context super effectively.
Yeah, specialization is one element, but then there's a lot of different elements of like why it makes people so effective. Specialization is like, oh, a person is like 10 times more effective doing one very specific task than if they need to do like 90 tasks.
Yeah.
But then I was actually talking about like the problem of what to work on is continuously refined by large groups. So like you may be doing something a certain way, but then one person is like, actually, let's do this different way. So like starting a new business that does something totally different, right? Yeah. Once you have enough people, some people are just going to want to do something totally different than what's currently being done. So do you imagine like your subagents kind of like leaving the team and then like working on a different thing just to do it better?
I think it probably depends on the task that is being asked of it. And there's probably some kind of tasks which are really hard to verify, where you do want this like very iterative grown process to happen. And there are some tasks that you like, for instance, it's not really ambiguous like how to complete this thing effectively. Yeah. Like maybe, and like the complexity of tasks where you want this like approximation based system is like, we want an agents to run our entire economy. Like you definitely want some way to approximate like a more efficient like engine of the economy over time. And like your first instinct, or the agent's first instinct on like how to solve this effectively, is going to be like dog shit, right? But also I could see just like if you have enough inference, that doesn't matter, right? Like if you take a hierarchical approach
Yeah.
and you're able to just like very quickly explore a certain path and then like come back and like alternate your hypothesis, then like you can quickly explore your like design space or whatever, and like this decentralized approximation approach is not actually needed.
Mm-hmm.
So it's also a function of just like we can't like you can't like perfectly take what we see in society with humans today and be like, this is how, you know, like super agents should work, because super agents have like different, like fundamentally different set of like physical bounds
Mm-hmm.
and like how they can work and the speed at which they can work. Right? Like if you could go and take humanity and make it work a million times faster, I'm sure you would have different ways of cooperating that emerge from that.
Yeah. So this is like imagining your central orchestration agent. Like it could just take the info that one of the sub agents told it about its discoveries and then choose to take another path down afterward.
Yeah. And also, I would imagine for these like super complex tasks, this orchestration agent is going to fundamentally know how to make a good hypothesis, like mathematically optimal hypothesis.
Mm-hmm.
Right? Like it can go and be like, you know, there's like 100 reasonable ways to solve this problem. Let me spawn an agent to like go through and evaluate each independent hypothesis.
Yeah.
And then like double down on the ones that are starting to like make sense.
Mm-hmm.
And so, yeah, I'm kind of, if you ask me personally, I'm kind of like bearish on the idea that you need like this decentralized, like
people analogous.
Yeah, like agents approximating the correct solution over time.
Yeah.
At least for, definitely for like the majority of problems that humans face on a day-to-day basis. So the way I kind of explain this is like super intelligence in 5 or 10 years is a system that can solve any human problem. A human can go to super intelligence and be like, make my mom healthy or something.
Yeah.
I don't know, right? And if we have super intelligence, then it should be able to solve that, barring it doesn't like violate like the laws of physics, right? It's not gonna like bring your mom back from the dead.
Yeah. Wait, so what does your multi-agent system help that a single agent can't do or does so much slower today?
So today it can orchestrate, well, let me put it this way. Let's say you just want to buy some kind of good or service, and you want to evaluate like a bunch of different vendors all at once. With a single agent system, I know you can like they can spawn sub agents, but that's roughly bounded, right? But like with a multi-agent system, you can go and evaluate 100 different vendors all simultaneously, and also like cross negotiate against them. So essentially, as a buyer, I am now buying goods from a way more efficient market for whatever market that I care about, right? It could be anything from I need a lawyer for my startup to like I want the best flowers in the city to XYZ. And you're just going to get like this like 10, 20, maybe even 30% like decrease in the cost of the thing that you're buying because of its ability to like parallelize super effectively.
And just do broader, deeper search in the same amount of time.
Yeah.
Okay.
That's one example.
So like the modern competition is kind of like the what is it called? I want to say it's Llama has like a harness that does it's called like Llama Index. I think there's a harness that they have that's just like called Deep Research that basically spawns like I don't know like 5 or 10 agents that then all research like basically similes of your query, right? So is that like your current starting point of like the analogous product?
So in some sense, the main difference between our harness and something like Llama Index, whatever you said, is our harness is specifically made to take action in the real world.
Yeah.
So if you need to just do a bunch of web searches in parallel, like, yeah, there are existing tools that can do that. But if you need to go call a bunch of businesses in parallel, or spawn a bunch of browser agents in parallel, or do a bunch of like messaging in parallel, or emailing in parallel, then there isn't a good harness for that.
Okay, this reminds me of a product that the company Giga had. They're like one of
The
the,
voice agent.
yeah, exactly, because they do multiple phone calls at a time.
Mm-hmm.
So they can like kind of have the AI decide that these two people need to meet at this exact moment and then call both of them at the exact same time.
Oh,
And then if they both pick up, then you can like just connect
merge
them.
the
Yeah,
calls together.
exactly. You can even call like more people than that. If you need to call someone who like runs the gate and then like the person at the house and the door dasher, like you can like do many, many party coordination. And so like this is a possible angle.
Mm. Yeah, I think also part of the issue too is like there are ways to do what my system does with a lot of like different types of tools.
Yeah.
So you can use like one tool to do like mass phone call parallelization, and one tool to do browser agent parallelization. And you also, for the browser agents, need like some way to get around anti-bot. The point is like, in order to actually have a system that can go and solve almost any problem you want right now,
yeah,
you need to like create this like hodgepodge of like 8 different types of tools and like figure out which ones work and like probably update the underlying tool implementations and stitch them onto Claude. It's like it's technically possible with like just Claude or just Codex, but it's just like a massive amount of pain that no real person is gonna like go through in order to like, you know, get that end reward.
Okay. And are you also like planning out farther ahead than a traditional agent? Because like based on your description, it's like you want to plan out far. If you need to coordinate many more agents and also do longer tasks, like how do you actually get the same AI model to plan out farther, like or plan long tasks better? Like what does that even mean?
Yeah, so there's one approach that the industry is taking, which is to do like all the plan in one shot.
Mm-hmm.
And so I think like Anthropic's workflows, right, where you spawn just like 200 agents.
Yeah,
Or
yeah.
you write code that orchestrates 200 agents. And I think that's like fundamentally a faulty way to approach the problem because you need to do, how do I put it?
Plan updating.
Yeah, you need to plan updating. You need to like adapt your, you need also to be like, be able to shove a ton amount of compute into this really extended plan. And yeah, I just don't, I guess fundamentally I don't see like Fable 8 being like solve cancer and it's just like a million agent plan.
True. True.
So the approach I've taken is like, okay, the planner, it doesn't go and fully decompose the whole tree in one shot. It just breaks it down to the next step. And because you can just, you know, have this planner take care of this one isolated small action, you can shove a bunch more compute into like the creation of this entire like super long horizon plan. Right? Because now you have like hundreds of LLM calls all along the way. And there's a bunch of other benefits too, to like, you know, building the plan iteratively over time. Like you mentioned, being able to adapt your plan. So like if some sub problem fails, it shouldn't go and like deconstruct like the whole workflow, right? You should be able to isolate and just update this one plan.